So this is user interface for NetXMS. It is connected to a server in our office. This is how user interface usually looks like. On the left, you see this selector panel where you can switch between different parts of the system. We call it perspectives. So this is an infrastructure perspective. Basically, it's where you can create your own logical hierarchy of objects that you monitor. So you can create groups we call containers. They basically serve for logical hierarchical grouping of managed objects. You can create any level of nesting. So for example, here we have our top level object infrastructure services, and then we have a data center group, and then we have 3 data centers. And inside the Latvian, we have other groups like ATMs, demo systems, etc. And then finally, you place your objects, your servers and devices into some group. And device can be part of multiple groups. So you can have a division by geographical location, and then you may have another division by vendor or by responsible persons, etc. When you select something on the left navigation tree, on the right you have context information for selected object. So currently I have selected the top level object, which is infrastructure services, and I can get alarms for everything inside and other kind of overview information. Like for example, I can go to the status map and get it like a map of colored boxes that represents the status of each device within that group. And if I go down, for example, I will see only objects that within selected group. I can go to the network, and I see only what is within the network group. When I select an actual device, for example, here, this is actually a switch. So you see that the context views are different now. So first of all, you have your overview where you can get basic information like what IP address we use to communicate, what it is, its capabilities, when it was called, and so on. So here we see that okay, this is a Zixel device, that product name, version, serial number, etc. And in the capabilities, we can see that it's has bridge capabilities because it's a switch, and it supports entity MIP, it supports LLDP, SNMP, version used is version 2, and so on. You can check alarms for specific device, as that particular device does not have any alarms currently active. You have a data collection where you can collect, you can see what metrics are being collected. Again, nothing here, we can select something else. Here, for example, it's another switch, and we collect inbound and outbound traffic on different ports on it. And also we collect the CPU temperature and so on. And if you, from here, you can quickly get to the line chart of selected metric. Basically, you just double click on it, and you will get a line chart for an hour by default, and you can quickly change it using the presets, like I want it for last 12 hours, for example, or you can go to the properties of the chart and use any custom interval, like a chart for 9 hours, for example. So I get charts for 9 hours. And also, of course, you can get a textual form, the history of the metric. And you see here we have a value and we have a raw value. And this is part of our data collection. You can actually define any transformation for the data you are collecting. So in our case, device reports tenths of a degree, and we can just convert it to the degree basically by dividing it by 10. We have the performance view, which is user configurable set of metrics that should be displayed here for quick access. So you can define, okay, I have some key metrics that I access very often, and you in a configuration you define, okay, it should go there to the performance view. You see all the interfaces of the device, which is good for network devices. You see a lot of information, MAC address, type, speed, etc. For the switch, one of the useful things is that you see the spanning tree state, so fast forwarding, blocking, learning, and also here you see the peer information. So system automatically collects network topology whenever it's possible, and you can see in different forms what's connected where. So I can select an interface on the switch, and I see, okay, that to that interface connected device called E62 with its interface VM NIC0, and so on. And this is on the last column. You can see the source of this information. So in that case, it's LDP. Here, for example, we get information from switch forwarding database, and so on. We have different mechanisms for collecting the topology information. And of course, you can also get this in a graphical form. On the hardware inventory page, you can see information about the hardware. Actual information depends on, of course, on what the device can report. So for SNMP-based network devices, it's usually based on NTTME. So this is a different vendor. This is Syslog, and they provide more detailed information. So you see all the ports, the modules, etc. This is Dell, again, only one line. You can see the graphical representation of switch ports, just for quick understanding which port is up, which port is down. You have access to switch forwarding database. So you see what's currently inside switch forwarding database. And if the MAC address is known to the system, you will also see the name of the device. You can see ARP Cache, again, not very interesting on the switch, but could be quite useful on a server. So if we try this, so this is a firewall, and you see it has a lot of addresses in the ARP Cache. You can see VLANs when when this information is available. This switch is a MikroTik, so it's not available. If we go to another vendor switch, you see information about VLANs and what interfaces are in what VLANs. Routing table, again, would not be much of interest on the switch, but on the routers and servers could be useful. We also have, for SNMP devices, you also have SNMP MIM Explorer, where you can just explore MIM tree. And also you can, on any level of the MIP tree, you can right click and choose Walk, and you will get output of SNMP Walk on the selected device for selected subtree of the MIP. And if you want to start collecting this data, you can just, let's do Walk on the system. You can just right click here, for example, here, right click, and you have the option create data collection item, where you can do some fine tuning and press OK. And now if we go to the data collection, we have a new metric, and it already has start collecting values. So the configuration of data collection directly from SNMP MIP tree is would save a lot of time when you set up the system. A little bit about data collection. So you can collect a lot of metrics from different sources. So if we look here on the Linux server, for example, we can see that we have a lot of metrics. You can edit directly from here. For every metric you collect, you have the origin. Could be our own agent, SNMP, web service, script, SSH, etc. A lot of options, a lot of sources for it. The name of the metric depends on the origin. So it will be OID for SNMP, it's a metric name for an agent, and so on. And you have your display name for the metric. Then you can define the data type, optionally measurement units, multipliers policy, like if you like to show it with multipliers. Like here, for example, we have a big value and it's shown in megabytes. You can define collection schedule. It could be the server-wide default, or it could be any custom interval, or you can define advanced schedules where you can set, like if you want to collect this only on work days from 9 to 5, it's all possible. And you can, for each metric, you can define retention period. Again, usually it's just server default, but you can define any custom retention interval, or you may choose that this metric should be collected, but not saved to the database. So maybe it's just used for some calculations or for displaying on a dashboard, but you are not actually interested in history. That's also possible. You can do transformation on collected data before further processing. And the transformation consists of two steps. First, you can choose to calculate the delta, which is very useful when you have cumulative counters, like for traffic on the network interfaces, for example. And then you have an option to use a transformation script where you can do any custom logic. We have our own built-in scripting language, which is quite powerful, and you can do a lot of interesting stuff here. You can also access values of other metrics, so it's possible to do a calculated metric based on multiple measurements, even from multiple devices. You can set thresholds. So if we go to the different metric, you see that we have a threshold here, and this is quite simple threshold. So if last value polled from this metric for 5 consecutive polls will be greater than 2, we will generate a specific event. In that case, that this queue is too high. And if when condition is no longer true, then the deactivation event will be generated. You can also choose to repeat event if condition stays for a certain period of time. And you have different functions. So it could be average, mean deviation, absolute deviation. So sum of values for given number of polls and so on. And for complex logic, as in many other places of the system, you can use scripts. So you can create your own scripts that can do some complex calculations or logic and just return true or false to indicate that the condition is true or false. For simple functions, you can use the operation here, like less, greater, not equal, and so on, all pretty straightforward. Instant discovery, it's a very useful concept when you have multiple entities and you don't know from the beginning how much you will have. For example, it could be file systems, it could be network interfaces, and so on. And using instant discovery, you can configure the system to automatically find instances of this metric, of these entities, and create data collection element for each entity. And we use it a lot, and it really helps with automation of monitoring. On the performance view, this is where you can actually indicate it. This metric is important for me. I want to see it on the performance view. Again, very simple. You have your options for tuning how the chart will appear in the performance view. You can have metric level access control. So you can restrict who actually can see this metric. And some other very specific options for fine-tuning how you collect and how you present this metric. Another very important part of the system is event processing. So we collect data. We also do some polling when, like, if device is reachable, if all interfaces are up, and so on. And if something happens, the system will generate event. Threshold is violated, event will be generated. If interface went down, event will be generated, and so on. And all events will go through the what we call event processing policy. This is our event processing policy. It is basically a set of rules that define that has a filter and an action. And in the filter part, you define how to match your event. It can be quite complex. So, for example, if you look at this rule number 3, we check that if the source of an event is within one of those containers, except if it's within one of the subcontainers, and if we have a sysnode ARP event, which means that the device is reachable again after outage. And then we have an action that will send a notification to a specific channel. And you can have different actions. It can be notifications, you can run commands, you can run internal scripts, or you can generate alarms. So basically, this is how you get alarms in the user interface. And it's through the event processing policy. Like here, if we have a node down event, which means that the server cannot reach the device, we will generate an alarm. And we will get, when we get opposite event, node up, so that connectivity is restored, another action will be executed, which will terminate an alarm. So it's possible with correctly configured event processing policy to automatically terminate alarms when condition is no longer true. So you can actually, when you open your alarm browser, you actually see actual problems. You know if the alarm is there, then the problem is still there, if everything is configured correctly. And this is very powerful mechanism to handle anything that happens in your network, in your environment, and react to it. We have a network perspective, which is where you can see the all subnets, and it is built automatically. So whenever a server detects, finds a network interface, it will try to find appropriate subnet object. If it does not exist yet, it will create subnet object and it will place nodes behind under those subnets. So you can actually see, okay, I have a 10.3.00/24 subnet, and this is what devices I have within that subnet. Assets, it's asset management. So we have a built-in simple asset management. You can define your physical assets. You can link those assets to the monitored devices, and you can track the history of those assets. So we don't have it configured on this system, but it's possible to have basic asset management within the system. And the templates, that's a mechanism for simplifying data collection. So usually you have a lot of identical or similar devices, and you don't want to configure data collection on each of it individually. So you can define a template. And in a template, basically you have your data collection where you define metrics as usual. And then you can see like where this device is applied. So it's like few Cisco devices because it's a Cisco template in that case. There are multiple options how to actually apply template to the device. One is just do it manually. So you right click and choose apply to, and you can select the device where to apply. And other option, which is very common, is that in the properties, you have what we call automatic apply rules, which is basically a script. So this script will be evaluated against each monitored device in the system. And if script returns true, this template will be automatically applied to such device. So in this case, we check that device supports SNMP, and SNMP OID start with specific string, which is a Cisco private OID. So basically, it will be applied on any Cisco device with SNMP. And if you have your automatic apply rules set correctly, you don't need to do anything when you add a new device, because it can be found by automatic network discovery. Then all necessary templates will be applied automatically using those automatic apply rules. And we actually have the same mechanism for containers in an infrastructure. So you can, on any container, you can have this same automatic binding. So you can define a script, like which to place into container, and it will be placed into appropriate containers automatically. Like here, for example, we have a MikroTik container, so where all MikroTik devices should be placed automatically. And you see, we can easily find all MikroTik devices we have in monitoring. And if network discovery will find another MikroTik device, it will be automatically placed into that group. Then we have dashboards for visualization. You can build a lot of different type of dashboards. So this is one example. We have like around 30 different elements that you can put on dashboard: charts, maps, text fields, etc. Check this. So this is another thing for Postgres health monitoring. And so on. Graphs. It's kind of similar to dashboards, but it's just graphs. So you can quickly get access to certain predefined graphs. And when you do something here, like I'm here on my page, for example, I want processor temperature, and I tweak it a bit. For example, it is day, and I can go to properties and change something. For example, and so I did some tweaks to my chart, and maybe let's this. And now I can do save, and I can just give a name to that graph, save it, and now if I go to my predefining graphs, I have my new graph, and if I click on it, I will get it with exact same settings as I've saved it. So it's just a way to quickly save charts for quick access. Network maps, we have manual and automatic network maps. So you can build maps automatically based on network topology, or you can create map by hand. This is the example of some custom map. You can have objects, you can link them, so you can just add another object to the map, move it around. You can select two objects and link them together and so on. There is an automatic map. So this, for example, is automatically built topology map for a lab environment. This is another example of automatic topology map. You can zoom maps in and out. You can change how the objects are represented. So here you call it large labels. So you see there's a lot of information about the device on the label. You can switch it to other modes, like to show just icons of the objects and so on. And actually, we are now working on version 5 of NetXMS, and in version 5, we will have significant improvements in network map functionality. Alarms is just a way to see all alarms in the system. And you can also double click on an alarm and get details for that specific alarm. And each alarm can have comments, so you can add comments. And then you see like who and when added the comment and so on. And when you go to the alarm list, you can see that this alarm has comments and how many comments it has. Business services, it's another kind of side feature when you can define the services from business perspective. And basically, each service is a combination of different checks. And if all checks returns a success, it means that service is operational and it's running. And if at least one check returns failure, that means the service is not working. And then you can get an availability report for the service and see if it's working or not and how much it is working, how good it's working. We have a reporting integration. It's not configured on this server, but we use Jasper reports, so it's possible to define reports and execute it directly from user interface. There's a lot of different logs in the system. Most commonly used is an event log, so all events are logged in the database, and you can search those events from here. So you can define a filters. For example, I want events for specific objects. So yeah, define the object, run it, and I have my events for specific objects, and so on. We have SNMP traps, Syslog, logs, audit log, so we can see who does what and when. It's also possible to send audit log to external system. We have real-time monitors for events, incoming SNMP traps, and incoming Syslog messages. So you can just put it on your screen and watch in real time how events goes. Don't have much activity in the system, so no events at this moment. Different kind of tools, like you can find an object in the system using the query script or just some manual filters. You can search for specific IP address or specific MAC address in the network. There's a debug console for the server where you can get some insights and debug information about the server itself. We have a world map view, so you can see actually that kind of a map, and you can actually place devices on the map, so you have your geographical location for the device. So I can, for example, right-click on a place choose that I want to place object here. That will be this object, and it will be displayed on the map. And after that, if I go to the this machine, where you see it will get a geolocation context view. And if I go there, it will show me the geographical map centered around this device. So if you have something in the field, you can actually set the locations and you can see on the map where exactly this device is located. And we use OpenStreetMap. We have our own tile server, which we host, which is a default tile server when you install NetXMS, but you can set up your own tile server if you want, with your own map rendering and so on. And this is a configuration view. So there's a lot of configurations possible, a lot of small tweaks and etc. We won't go in details through this. Now, a little bit about the security and user management. So NetXMS has its own internal user database, so you can define users directly in the NetXMS. It's also possible to connect external directories through LDAP. So you see here, for example, we have some users coming from LDAP, and then LDAP users are synchronized, so they can use their external login and password to get into the system. And within the system, you can give access rights to them as in the same way as you do with internal users. And you can mix and match them. So you can have a local group and you can add LDAP users to the local group, or you can synchronize LDAP groups, for example, from your directory. And there are different set of rights. So there are system-wide access rights that define basically what you can configure in the system for most part. You see like a lot of different access rights here. And also we have an object level access rights. On any object, you have your access control properties. And here you can give different access to the object. And those rights are inheritable. So here you see they all grayed out because they actually inherited from the upper level. So if we go to the top level, you see this, there you can actually edit them. And again, there's a lot of access rights on the object level to just read, to modify, to create sub-objects, etc. So that was a real quick overview